Hi everyone, I'm Kelly from SMK GHAFAR. Today, my friends and I are going to share you about the knowledge that you must know about soup. Let's get started.
Hello everyone, I'm Shing Yi from STEM 1. Saponification is a process by which triglycerides are reacted with sodium or potassium hydroxide, lye, to produce glycerol and a fatty acid salt called soap. Triglycerides are most often animal fats or vegetable oils. When sodium hydroxide is used, a hard soap is produced. Using potassium hydroxide results in a soft soap. While the one-step triglyceride reaction with lye is most frequently used, there is also a two-step saponification reaction. In the two-step reaction, steam hydrolysis of the triglyceride yields carboxylic acid rather than its salt and glycerol. In the second step of the process, alkali neutralizes the fatty acid to produce soap. The two-step process is slower, but the advantage of the process is that it allows for purification of the fatty acids and thus produce a higher quality soap.
Hello everyone, I'm Li Choo from STEM 1. The soap manufacturing process can be separated into two main groups, the kettle process and the continuous process. The kettle process produces soup in one batch at a time, while the continuous process makes soup continuously. Most big soup manufacturers use the continuous soup manufacturing process because it produces a more consistent product. The continuous process also creates soup faster, producing soup in about 6 hours compared with the 12 to 11 days the kettle soup making process takes. In the continuous soap manufacturing process, molten fat is sent into container where hot, high-pressure water is sprayed into it. This separates the fat into component parts. The fatty acids are then purified and sent into another container, where the alkaline substance is added. Once the soap is made, some manufacturers may whip it into incorporate air. The entire mixture is then poured into mold and allowed to cool, or it cooled in large slabs that can be cut later. The first step of the kettle soap manufacturing process is to boil the fat and the alkaline substance together. Salt is then added to allow the soap to separate from glycerin, which sink to the bottom of the container and is removed. After this, the soap is pitched, water is added and the liquid is boiled. This causes the soap, called neat soap, to rise to the top and the water and other substances, collectively called nitrate, to settle at the bottom. The soap is removed and like soap made using the continuous method, is cooled in mold is allowed to cool as a large slab to be cut later. Soap has its economical value. Soap is easy to produce, readily soluble, does not spoil, and transport easily. Its soap can supplement household income. Furthermore, soap made with mixed tree oil is more affordable than the raw oil itself. Through the project, it was found that women are particularly interested in new economic activities which produce direct financial benefit for them and their families. However, the additional works must result in immediate, tangible benefit to ensure continued adoption. A recent study on the environmental impacts of soup and their associated packaging found that bar soup have a lower environmental impact than liquid soup in many important categories, including carbon footprint, ozone depletion potential, and eutrophication potential. This is due largely to the higher energy requirements of producing the raw materials and packaging for the liquid soup. Lesson here for the environmentally conscious shopper is that product selection is really a black and white issue. Deciding which product to buy often comes down to decide which environmental impacts one personally is most interested in alleviating. Most of the dust on our skin is removed thanks to the soap that we use for the sole purpose of cleaning it, but we may be causing more harmful to our environment in the process. Soup made of chemicals and resulting runoff from our bath, which often consists of soapy water, dust particles, grease, and various chemicals, is released directly to the local environment. It may not seem like much, but this is bound to affect the environment to an extent. Besides, soup will also cause some negative health effects to humans. One of the negative health effects of soup is allergic reactions. These days, soup are more chemicals than anything natural, and naturally some of them are bound to cause our allergy to flare up.
One early indication that we have an issue with soup in question is when our skin breaks into a rash and even develops hive. That's an indication that we are allergic to that particular soup and need to consult a doctor to help mitigate the allergic reaction. Soup may also cause dry skin. As we know, soup often comes with an increased pH, which, while being effective in removing the bacteria from our skin, can cause it to dry up. Dry skin condition can cause our skin to become more easily brushed. That's why we need to go for a soup come with some amount of moisturizer, or we can always apply a moisturizer after we finish taking our bath. Let us perform an experiment by using soup. The materials used in these experiments are 2 containers, 1 bar soup, distilled water and tap water. First, fill the containers 1/3 full with tap water and distilled water respectively. Then, put the bar soap in the distilled water and rub with hand vigorously for a few seconds. After a few seconds, put the soap in the tap water and rub it too. And we can observe the water. The water with more lather is soft water, while the water appears cloudy and have scalp is hard water. When soup is added to hard water, the calcium and magnesium ion present in hard water react with soup. The sodium salts present in soups are converted to their corresponding calcium and magnesium salts, which are precipitated as scum. The insoluble scum sticks on the clothes, and so the cleaning capacity of soup is reduced. That's all. Thank you for watching our video. Hope you like this video and have a nice day.